discuss finite element methods. The finite element method has become a powerful tool for the numerical solution of a wide range of engineering problems. The finite element method has become a powerful tool for the numerical solution of wide range of engineering problems. The application of the FEM, the deformation and stress analysis of automotives, aircraft, buildings and bridge structures to field analysis of heat flux, fluid flow, magnetic flux. Next, stresses and equilibrium. A three-dimensional body occupying a volume V and having a surface S as shown in figure. The points in the body are located by x, y, z coordinates. The boundary is constrained on some region where displacement is specified. This is the boundary. On a part of the boundary, distributed force per unit area, T, also called traction force, is applied. Under the force of the body deforms, the deformation of a point x, y and z is given by the three-dimensional components its displacement. U is equal to u, v and w. So write a vector form u, v, w whole power transpose. The distribution force per unit volume, for example, weight per unit volume is the vector force. F is given by F is equal to f of x, f of y, f of z, f of x direction, f of y, y direction, f of z, z direction. The body force acting on the element volume dV, the surface traction T, may be given by its component value at the point in the surface. T is equal to T of x, T of y and T of z whole power transpose. The example of traction are distributed contact force and action of pressure. A load P acting at a point Pi is represented by its three components. P of I is equal to P of x, P of y, P of z whole power transpose. The stresses acting on the elemental volume dV as shown in figure. When the volume dV shrinks a point, the stress tensor is represented by the placing its components in a 3 by 3. The symmetric pattern. Sigma is equal to sigma x, sigma y, sigma z, tau of yz, tau of xz, tau of xy whole power transpose, where sigma x, sigma y, sigma z are normal stresses and tau of x, tau of yz, tau of zx are shear stresses. Let us consider the equilibrium of the elemental volume. Sigma f of x is equal to 0, sigma f of y is equal to 0, sigma of f of z is equal to 0 and dv is equal to dx, dy and dz. It can be written as dou by dou x of sigma x, dou by dou y of tau of yz, xy plus dou by dou z of tau of xz plus f of x is equal to 0, dou by dou x of tau of xy plus dou by dou y of sigma y plus dou by dou z of tau of yz plus f of y is equal to 0, dou by dou x of tau of xz, dou by dou y of tau of yz, dou by dou z of sigma z plus f of z is equal to 0.